Today we want to talk about radians, which is another way to measure angles. We have the familiar 0 to 360 degrees for a full circle. Radians are just a different way of measuring angles. Like we have degrees Fahrenheit, we have degrees Celsius for temperature. We've got degrees and radians to measure angles. So here's where radians, how we define radians. We take a circle. We take a circle, and the circle has a particular radius. A circle has a radius. Let's call it R. We take a line segment, the length R, and we start wrapping it around the circle. The idea is that we're going to curve one radius around the circle. So that curve distance is R. Take a piece of string that measures the radius of the circle and then start wrapping that string around the circle. And then go back to the origin. Trace that back. And the angle that you make at the center is 1 radian. So that's how we make a radian. How we define 1 radian. It's a way that we measure an angle. So 1 radian is about 57 degrees. Right now, all this needs to be is another way to measure angles. The reason is that when we started taking the sine and cosine graphs and we started stretching them out horizontally, we ended up with a graph that had nice sinusoidal periodic graphs. So they're great for modeling things that go up and down and up and down. But we want to make them not functions of angles like we've used them so far. We want to make sine and cosine functions of real numbers. And so that means we want to start measuring in radians rather than in degrees. All right. So if we go all the way around the circle, that's going to give us 360 degrees. If we go all the way around the circle, what is that like? What is the circumference of a circle as a function of the radius? What's the circumference of a circle with the radius of R? So here's the radius. What's the circumference of the circle? That's the area of the circle. What's the other one that we know for a circle? 2 pi r. Just put the 2 in front instead. So the whole length around the circle is 2 pi times the radius of the circle. What this means is that 1 full circle, that angle will be 2 pi radians. So one full circle is 2 pi radians. So 1 radian, we have an arc length of 1 r. So if we go all the way around the full circle, that arc length is going to be 2 pi times the radius. So that angle that we make will be 2 pi radians. So going all the way around the circle, that would be 2 pi radians because our circumference and here our arc length was 1 r. So with an arc of 1 r, we have an angle of 1 radian. So if our arc is 2 pi r, our angle is 2 pi radians. What's one full circle in degrees? If we go all the way around the circle, how many degrees is that? 360. So that means that 360 degrees is equal to 2 pi radians. (360 degrees is equal to 2 pi radians. So what's a half of a circle going to be? What's 180 degrees equal to? How many radians will that be? Pi. Divide both sides by 2. So 360 divided by 2 is 180. 2 pi divided by 2 is pi. So if 180 is pi radians, what's 90? If I divide by 2 again, what's 90 degrees? How much? We'll just cut it in half again. So we'll say half of a pi, or we'll say pi over 2. So 90 degrees is pi over 2 radians. If I cut 90 degrees in half, I get 45 degrees. If I cut pi over 2 in half, what do I have? Not pi to the 4th, pi over 4, pi divided by 4. If you want to cut a fraction in half, just double the denominator. If you have twice as many people, each person gets half as much. That's 90 if we divide it by 2. So pi over 2 becomes pi over 4. What if I take 90 and divide it by 3 and have a 30-degree angle? So if I take 90 and divide it by 3, 90 divided by 3 is 30. What's pi over 2 divided by 3? So when we divide by 2, we multiply the denominator by 2. So if I divide by 3, I should multiply the denominator by 3. 2 times 3 is 6. So 30 degrees is pi over 6. Now, if I take that 30 degrees and double it, so 2 times 30 is 60. Two times 30 is 60. And if I take 2 times pi over 6, I got this fraction 2 over 6. What do we get when we simplify the fraction 2 over 6? We'll end up with pi over 3. So here are some radian measures that we want to recognize that are familiar. We wanted to know 30, 45, and 60 going all the way around the circle. Here are those angles represented in radians. The main thing we want to remember is that 180 degrees is pi radians. 90 is 180 divided by 2. 60 is 180 divided by 3. 45 is 180 divided by 4. 30 is 180 divided by 6. This is why we like 360 so much. It's divisible by lots of things. So now that we see 30, 45, and 60, and 90 expressed in radians, the next thing we want to do is just take these 30, 45, and 60, and 90 and find their radian equivalent reference angles going all the way around the unit circle. Because like I said, we have to know the unit circle really well. So I didn't pre-draw my unit circle. So I've been running late all day. Let's grab a unit circle. Middle right there. So what we want to do is we want to go around the circle and write the degree and the radian equivalent for all of our common angles, our quadrants, and our 30, 45, and 60. Because once we know the unit circle going around, forever, we just repeat. So 0 degrees is 0 radians. When we're listing angles in radians, we don't put units. We just understand them to be radians. They're unitless that way. Up at the top, we have 90 degrees. 90 degrees is pi over 2 radians. Halfway up at 45 degrees. 45 degrees is pi over 4 radians. We know that at 180 degrees is pi radians. The way I want to think about this is I want to think in terms of fractions. I want to count in terms of fractions. I want to split this up by fractions and I want to count in terms of those fractions. So I'm going to start with pi over 2, or sorry, pi. So 0 degrees is also the same location as 360 degrees. And 0 radians is the same location as 2 pi radians. So if we count by pi, where pi is a half of a circle, I start off at 0. 1 pi is 180 degrees, 2 pi is 360 degrees. So I just went half the circle, then the other half of the circle. Now I want to count around the circle in fractions of pi over 2, in quarter circles. So I'm going to start off at 0, then I'm going to go 90, 180, 270, 360. That's counting by 90s. 90, 0, 90, 180, 270, 360. So counting around the circle in terms of in terms of 90. 0, 90, 2 90s is 180, 3 90s is 270, 4 90s is 360. Now we're going to count in pi over 2. 0 pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Just counting around fractions. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Just counting around in fractions. Because we're trying to remember where things are. I want to associate over 2 with 90s. Over 2 gets associated with the 90s. So 0, 90, 2 90s is 180, 3 90s is 270, 4 90s is 360. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Count around pi over 2. Let's cut it in half again, and we're going to count around in 45s. Here's 1 45, 2 45s is 90, 3 45s is 135. 4 45s is 180. 5 45s is 225. 6 45s is 315. 6 45s is 270. 7 45s is 315. 8 45s is 360. Counting around in 45s. Now we're just going to replace the 45 with pi over 4 so we can count around in radians. So I got 0, got 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. Just count around in pi over 4s. Associate pi over 4 with 45 degrees. 1 pi over 4. 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. The 4 that stand out are the ones that have a 45-degree reference angle or a pi over 4 radian reference angle. The ones at the quadrants are multiples of pi over 4, but we have better names for them. Rather than saying 2 pi over 4, we're going to simplify that to pi over 2. So the important ones to note from here, at 45 degrees is pi over 4 radians. 135 degrees is 3 pi over 4 radians. 225 degrees is 5 pi over 4 radians. 315 degrees is 7 pi over 4 radians. You don't have to memorize these values, but you do have to remember them. You have until now to remember these 4 values. Has everybody got it? Let me qualify. There's not going to be a quiz right now. Has everybody got it? Yeah, that changes your answer. I was like, oh, there's a quiz right now. Has everybody got it? You'd be like, oh no, let's postpone the quiz. I'm like, oh, there's not going to be a quiz right now. So, okay, then I'm comfortable lying to you and saying, yeah, I got it. Any questions? Comments? Everybody looks so happy. Everybody's pissed off because it's like fractions. It's like, oh, dude, 360 is so fucking awesome. It's divisible by all these things. And now you want to introduce fractions? Furthermore, half of a circle is pi radians and a quarter of a circle is pi over 2 radians. Why isn't a quarter of a circle pi over 4? I'm like, well, dude, that's what I was arguing for back in the day when we came up with pi. But they're like, oh, no. The circumference of the circle is going to be the radius of the diameter. Pi is going to be the radius of the circumference of the diameter, not, sorry, the circumference, the ratio of the circumference to the diameter instead of the radius. I mean, we still have pi day, but it would be on June 28th because pi would be 6.28 instead of 3.14. And they're like, oh, that's why. That was the primary reason why. It's like, well, because like pi day would take place late June where students are out of school. So we wouldn't be able to have a school thing where all the mathematicians have like pi day shirts and shit. I'm like, well, what are you guys talking about? June doesn't even exist yet. And they're like, well, we saw the future, Leach. So sit down. Pi is going to be 3.14. So you're gonna remember these numbers by counting around the circle in fractions of pi over 4. You can think 45 degrees. You want to associate 45 with pi over 4. Because notice that everything over 4 has a 45-degree reference angle. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Those are your 4 pi over 4s in quadrant 1, 2, 3, and 4. If it's an even over 4, like 2 pi over 4, that can be simplified. So you're not going to think of 2 pi over 4 as being in some quadrant somewhere. You're going to see 2 pi over 4, think that's pi over 2, and you're going to know that pi over 2 is up here at the top at 90 degrees. Because you're associating over 2 with 90. That's why down here, 270, 390s, 3 pi over 2s. How's everybody okay? Of course we are, because we all love fractions. They're our favorites. It gets messy to do it all at once on one circle. So I'm going to grab another circle. We're going to be dividing by a different number, so I want to put the ones that we're going to hit. So we've counted through the circle by pi over 2 or 90 degrees. We've counted around the circle at pi over 4 or 45 degrees. Now I want to count around the circle of pi over 3. Because now we're cutting things in thirds. So I'm going to go about halfway here and then up to the circle, and that's going to be 60 degrees. I'm going to go halfway on the X and then up to the circle, and that will be at 120 degrees. Halfway on the X, cut to the circle, and that's going to give us a 240 degrees. Halfway on the X, cut to the circle, and that's 300 degrees. We saw on the previous page that 60 is pi over 3 because I've taken the 180 and divided it into 3 parts. So 60 degrees is pi over 3. Now I'm going to count around in terms of 60. I'm going to count by 60s. 60, 120, 180, 240, 300, 360. So there are my dividing the 360 up into 60-degree angles. 60, 120, 180, 240, 300, 360. 160, 260, 360, 460, 560, 660s. Now we're going to count by pi over 3 in terms of radians. Sorry, we're going to count around the circle in terms of radians. 1 pi over 3, 2 pi over 3. 3 pi over 3. 4 pi over 3. 5 pi over 3. And 6 pi over 3. Notice that in each quadrant, we have a 60-degree reference angle corresponding to a pi over 3 radian reference angle. 60 degrees in quadrant 1 is pi over 3 radians. 60 degrees in quadrant 2 is 120 degrees or 2 pi over 3 radians. 4 pi over 3 radians is 240 degrees. In the third quadrant and in the fourth quadrant, we got 5 pi over 3. So pi over 3s are going to be 60-degree reference angles. Associate 60 degrees with pi over 3. The ones that we're going to want to remember are the ones that land in the quadrants. 60 degrees is pi over 3. 120 is 2 pi over 3. 3 pi over 3 can be simplified, so we just call that pi. 4 pi over 3, that's going to be 240. And 5 pi over 3 is 300. Everything pi over 3 that's not simplified is going to correspond to a 60-degree reference angle. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Is everybody okay? Yeah, because we love fractions, especially when they're divided by 3. We even have a special tape measure at home. It's not just 16ths of an inch, it's got thirds of an inch. Actually, I don't know if anybody makes that tape. People are like, oh, anti-fraction, and so they go, we should use centimeters, right? And it's great for like rulers, because like centimeters, you've got 10 places to count, but it's super difficult to eyeball. Like if I have some generic length and I want to cut it in half, that's a lot easier to eyeball than cutting it in tenths. You can cut it in half once, and that's 0.5, right? But then half again is going to be 0.25. Halves are better for eyeballing things. Anyway. It's kind of like when people complain about Americans measuring things in like washing machines and minivans and shit like that. You know what I mean? I don't know if I've complained about this before with this particular group of people, but it's kind of dumb to make fun of people for measuring things in washing machines. Let's suppose that I told you a sinkhole opened up in the parking lot and it was the size of a minivan. Imagine how big that hole is. Can you imagine that hole? Yeah, because you can imagine a minivan and you can imagine a minivan dropping into the hole. Now, what if I told you a sinkhole opened in the parking lot? It was 5 meters by 2 meters. Does that help at all? Imagine a hole 5 meters by 2 meters. How big is 5 meters by 2 meters? Let me give you a more useful measurement. It's about 1 minivan. Now you can picture it. That makes sense? Imagine something in your mind 300 feet away. What's a more useful measurement for 300 feet? A football field. Because America, right? You can picture a football field. Like, oh, I remember when I was staying on a football field, the other goalpost is about 100 and something yards, 100 yards away, that's 300 feet. I can picture that. But if I said, oh yeah, that guy was like 280 feet away, not useful. My favorite one was the washing machine one, because they said it was about the size of 7 washing machines. Michael, I can fucking picture that, because I've been to the laundromat and I've seen 7 washing machines. The only thing that pissed me off about that article was that they showed a minivan right next to the hole. I'm like, oh, fucker, you could have just used the minivan. You could have said it's like 1 minivan size hole. And you could, there's a minivan like right there for you to measure. You know what I mean? Yeah. What's the length of this pen? Here you go. Those of you looking playing at home. Here's the length of the pen. It's sitting on the paper, and the paper is letter sized. What's the length of the pen? The length of the pen is equal to 1 pen. It's not particularly long or short. It's about 1 pen long, right? If I said, oh, it's about the length of a pen, you'd be like, oh, a pen, huh? It's like, oh, yeah, about yay big, right? So, oh, it's about yay big because you put a pen in between things, depending on your hand size. You know what I mean? There are more useful measurements, and they aren't like numbers that break down in context. You know what I mean? When I'm measuring things, I'm measuring things in terms of finger measurements. How big was it? It was piece size. That's how big this circle is. The diameter of the circle is piece. What's the diameter of the paper? Hang loose is what the diameter of the paper is. What's half of a hang loose? Heavy metal, right? If things are smaller than that, if something is smaller than peace sign, right? It's like, oh, what's half of that? It's a Boy Scout. Or Cub Scouts. I don't know. It's a 2-finger one. Anyway. It's easier to cut things in half than it is to cut them in tenths. But we're going to cut things into sixths. So I'm going to go halfway up. See, halfway, easy to find. And that tells me where 30 degrees is. 30 degrees we know is pi over 6. That's definitely one we're going to know. We're going to count around the circle in 30 degrees. So 30 degrees is pi over 6. 2 30s is 60. We've already got that one covered. So there's 1 pi over 6. This is 2 pi over 6. But we got a better name for that. 2 pi over 6 simplifies to pi over 3 because we're awesome at fractions. And 2 30s is just 1/60. 3 30s is 90 degrees. Pi over 2 is the same as 3 pi over 6. We got a better name for 3 pi over 6. We call it pi over 2. That's 90. We got that one covered. The only one we need so far, 30 degrees is pi over 6. 4 pi over 6 is 120. 4 30s is 120. But we've got a better word for 4 pi over 6. We call that 2 pi over 3. 4 30s is 120. 120 is a 60 as well, so it's a 2 pi over 3. 5 pi over 6, finally a new one. I'm going to find it going halfway up on the y. And 150 degrees is 5 pi over 6. That's a new one. That's one that we need. We're associating pi over 6 with 30. So 150 is 5 pi over 6. 6 pi over 6, we've already got that. A better name for that. That's just pi. 7 pi over 6, that one doesn't simplify. It's a new one. I'm going to go down to -1/2. And 7 pi over 6 happens at 210 degrees. So that's 7 30s or 210 degrees. 7 pi over 6. 8 pi over 6. We got a better name for that. 8 pi over 6 simplifies to 4 pi over 3, making it a 60-degree reference angle, or 240 in the third quadrant. 9 pi over 6 is 3 pi over 2. So we're just gonna call 9 pi over 6, 3 pi over 2. That's 930 degrees. 930s is 270. 10 pi over 6, we got a better name for that one as well. But when we get to 11 pi over 6, halfway down, hit the circle at 330 degrees, there's 1130s. So that's 11 pi, I spelled 11 wrong. So 330 is 1130s or 11 pi over 6s. So there are, once again, 4 that we want to be able to recognize. Everything pi over 6 is a 30-degree reference angle. So the ones that we care about, the 30-degree reference angles are 30, 150, 210, and 330. So we're going to want to know pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So now we're going to want to count around the circle in radians. So 0 pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi. 7 pi over 6, 1, 2, 3. 4 pi over 3, sorry. 5 pi over 4, 4 pi over 3, 3 pi over 2, 5 pi over 3. The one I left out here is 7 pi over 4, 11 pi over 6, 2 pi. You don't have to memorize these values. You just have to remember them. It starts with pi, radians is 180 degrees. The ones we care about, 30 is pi over 6, 45 is pi over 4, 60 is pi over 3, 90 is pi over 2. When it comes down to typing these on, say, quizzes, to type something like, pick one with the numerator, 5 pi over 3, you would just type, as text, you would type 5 pi slash 3. Any questions? Comments? Spider marks? You don't have to memorize these. You do have to look for the patterns. Know what patterns are so that you can make the correct associations. Pi over 6 is a 30. Pi over 3 is a 60. Pi over 2 is a 90. Pi over 4 is a 45. Put those in all 4 quadrants. And learn your radians around the unit circle. All right, let's take a break and come back and try to remember where we left off.